Okay, 4.1 and 4.2, like I mentioned, are really more like one big giant section. There is a divide between them, and the divide is purposeful. The ones that we saw before had a lot of repetition of symbols, but the place values were very easily determined in one way or another, either because the symbol changed its sign, right? Like it looked different completely, like our Egyptians, or because we had a multiplicative feature, like the Chinese at the end, right? So there's some sort of a sense where we did this, and it was all kind of based on a base 10 system. You know what I'm saying? Everything sort of had this innate, like, tens built in. The tens are built in. The next two systems don't do that, and that's why they're separated. So we have next the Babylonian numeration system, and you notice there is only two symbols. So what are those symbols? Well, the first symbol is actually what you would probably think of as an upside down triangle. And I will tell you that when I draw it, I won't be filling it in. Okay? It's a what?
Tornado.
It's a tornado? Oh, you could do that. What's that? Yes. The real symbol, it will be filled in. But when I draw it, I'm going to leave them empty because I don't want to take the time to fill them in, just so you know. The value for 10 actually looks kind of like a less than sign filled in, or you could think of it like an arrowhead, a little bit like an arrowhead. And again, I will draw it just as a less than sign. So that's my shortcut notation. Okay, what's that? It's going to kick me out. Okay, wonderful. Now, they do repeated symbols. They do the repeated symbols for values that are less than 60. So if you had 58, you'd draw 5 of the arrowheads and then 8 of the triangles. Okay, like that's what you would do if the number's less than 60. It's very straightforward. Maybe tedious, may have a lot of symbols, but it's very straightforward. But if the number is bigger than 60, well, 60 or bigger, they actually do something slightly different. They actually have what's called a positional base 60 system. So our base system is base 10. We have the ones place, the tens place, the hundreds, the thousands, and they're all powers of 10. Their system is based on powers of 60. Okay? Powers of 60. So they don't have the ones place and the tens place and the hundreds place. They have the ones place and the 60s place and the 60 squared, or 3600s place. That's really different than anything we've seen so far. There's also an inherent really big problem with their system. As much as you didn't maybe like writing the 0 for our friends the Chinese, you're really going to wish that the Babylonians had figured out the 0, because it causes some major problems. They don't have one. So it means that their numerals are subject to misinterpretation. And I'll show you an example. This is a big flaw. Okay, go ahead and write down. I know these are beautiful because they're already on my screen. You can copy them and make sure they stay there next time. Feel free to draw them however you'd like, shorthand if you wish. So 2 of the arrowheads, triangle, 2 arrowheads, 2 triangles, and then number 2, very similar. So one of the nice things about all of our systems has been that if we have a repetition of symbols, we all seem to think I'll put the biggest symbol before the smallest one, right? And the Babylonians did it too. So we see the 10 symbols with the arrowheads in front of the triangle symbols. And what that means is that they're naturally grouped together. So right here, there is a break in grouping. I didn't put it in the right spot, so sorry. That's where I missed put it. Our 10 values, the arrowheads, in front of the ones places works just fine. But then I cross over my pink line and I have 10s again. That's bigger. There's a natural break there that means something different. And here's what it means. This is the ones place. It has a terrible color. I need it lighter. This is the ones place. And this one would be the 60s place. Okay? So you've got to figure out where the natural break is. The break will always occur when the values go from small to big. It went from triangle to arrowhead. That's small to big. It breaks the place value. Now, if I'm just counting above here, how much is 2 arrowheads in a triangle? It's 21. Arrowheads are worth 10, triangles are worth 1. How about 2 arrowheads and 2 triangles? 22. Okay, is that all right? Everybody see where the 21 and 22 came from? Okay. What it means is that I have 21 60s and I have 22 ones. Now, we don't have a $60 bill, so I can't use that analogy, so let me do a different one. Let's say you had containers of crayons or Legos or dice or whatever you want to use, some object. I want to use crayons. And you have 21 bags of crayons that have 60 in each bag. It's a lot of crayons. You might need them for STEM day, crafts and things that we're doing. It's very interactive. Yeah, you don't even know. All right, 60 crayons per bag, 21 bags. And then you have these extra 22 crayons all left over. Okay? But what we're trying to figure out in turning it into our system is really like how many total crayons do you have? That would be the idea. Well, we would multiply. So you would multiply 21 times 60, and you'd add 22 to it. And this section in particular is the first time that you're really going to need a calculator consistently when you're doing your homework. Because I don't think you want to do that by hand. You could, by all means, go right ahead. But you're not going to like what I'm doing next by hand at all. So, okay, what would that give you? Anybody have one today? 1,200. Okay, 1,260 plus 22, you're right,
82.
Which would be 82. So 1,282. That's this one. All right, let's look at the next one. Where do you see natural place value breaks? After triangles, right? And there's actually 2 of them, right? Because I have triangles shown in more than one place. Okay, cool. So again, this is the ones place, and this is the 60s place. What's this one? 60 squared. What's 60 squared? A lot. What's 6 squared? 36. So this is 3,600. 3,600. Okay? Within our place values, let's figure out how much we have. Okay, so before the first vertical bar, how much is 4 arrowheads and 3 triangles? 43. How about between my 2 vertical bars? Another 21. And then after or at the end, I have 11. So we will have 43 times 3,600 plus 21 times 60 plus 11. We do not need this many crayons. At this point, you better start giving them away. Surely some school needs them from you, right? How many is this? Do you have one back there?
156,071.
Sometimes I feel like there's about that many crayons in my house. Or markers or colored pencils, I mean. Yeah, 156,071. Okay. I think I have time to finish up this particular grouping. So let's do one more slide, and then I'll talk about what we do next. 3,280 in our system, and we're turning it into theirs, and then we have 43,205. Now, we already mentioned that we have the ones place, and we have the 60s place, and we would have the 3,600s place, because it's 60 squared. What's 60 cubed? even bigger, right, Madison? Mm-hmm. Somebody with a calculator, tell me what 60 times 60 times 60 is. I'm not going to put a comma so we can try to separate them. 216,000. That's big enough for our discussion, so I'll pause right there and writing them down. Okay, here's what we do. This is called a division scaffold. Our number is 3,280, correct? Okay, my list of numbers on the top. What is the biggest number in my list that will divide into 3,280? 60, right? 3,600 is too big. So what we're going to do is we're going to do something that looks like division, but it actually looks like the house part of the division is trapped. So we're going to have it on either side, okay? Looks like a top hat. The number that we're dividing, the 3,280, goes in the middle. And what we're dividing by will go on the left. So that's no different than what you've done before. So grab your calculator. I'd like for you to do 3,280 and divide by 60. I want to know how many whole numbers you get out, not the decimal part, just the whole numbers. Okay, 54 from the front row. 54. Nope, no rounding, just cut off the decimals completely. 54. Now I'd like for you to take 54 and multiply it by 60. 3,240, and we're going to write it underneath there and subtract. What's the remainder? Should be 40, yeah. And we're going to do it again. But we're going to go down in place value. I started with the 60s place. What's the next one down in place value along my list on the top? 1. So we put a 1. How many times will 1 go into 40? No calculators allowed. 40. Thank you. 40 times 1 is 40. Gives me a remainder of 0. I need a remainder of 0, and I need to have divided by 1 before I'm done with the process. So far, so good? Okay. How do I write 54? I need to write these values now in their symbols. How do I write 54? 5 tens and 4 triangles, stacked or whatever, right? How do I write a 40? 4 tens. And I'm done. It's a 2-step process. You've got to do a division scaffold, and then the values that come out of it on the right-hand side have to be written in their system. Okay, so here's what's going to happen. I'm going to keep recording so that those who are watching later, because we have a few people gone today, hear this. We're obviously not done with 4-2, okay? However, it is Thursday, which means from Thursday to Tuesday is the biggest bulk of time that you have to do homework from this class, correct? So while I'm not going to make this due on Tuesday, you're going to kick yourself if you don't do some of it before Tuesday, because you're going to end up with a lot due before Thursday, okay? So I'll postpone this to be due on Thursday next week, but I fully expect that we'll end up with 2 sections of homework probably due on Thursday, all right? So go ahead, and I would like for you guys to take with you, recognize that we're going to pick up on number 4 next time, okay?